Hello, everyone. Hope you're good. My name is Samuel Oladejo, and let me just go straight to this. No.
While a single A
Hello, everyone. I think there was just an issue with video, playing the video. I'll just try again using my local video player. Hopefully, this works out fine now. Sorry about the initial glitch. Yeah, so just okay. Let's try that one more time. And yes, just playing it again.
While a single AI agent is powerful, real-world, large-scale automation requires something more robust, a multi-agent system. Our next speaker will guide us through this advanced architectural frontier. He'll cover critical technical patterns like critique and reflection and sequential orchestration, and show us how to use Vertex AI Agent Builder to govern and deploy these complex systems at the enterprise level. Please welcome Samuel Oladejo as he presents the agent team architecting and governing multi-agent systems on Vertex AI and ADK.
Okay, nice. Sorry for the initial glitch. And let me just get straight into it. Thank you all for joining this talk. So to introduce myself, my name is Samuel Oladejo. I'm a software engineer with experience in building enterprise-grade fintech softwares and also a graduate researcher applying deep reinforcement learning to time series. And also I'm very passionate about ML and robotics. And so if you don't mind, the screen might just lag a bit, so it might be a bit delayed compared to my audio, but I'll try to, match the delay, so I wouldn't go too fast. so that everyone can be on board and we can all be on the same level. So, just introduce myself, and as you can see on the screen, that's just me on the side. And on to the next slide. So, this talk, architecting agentic systems, or rather, the agent team architecting and governing multi-agent systems on Vertex AI and ADK, came from all started from a talk I gave back in 2024 at the Devfest Johannesburg, where I spoke on democratizing AI, building a RAG system with Gemma and LangChain. So this talk basically was just introducing everyone to what RAG is, talking about how you can utilize RAG for the different things that you want to do. So we already have like your general chatbots, you already have like your Gemini and whatnot, but sometimes you want to ground that your information. You want to ground the model on your information. So maybe your company that you're trying to get more insights from all your PDFs. You have like terabytes of terabytes of documents that you're trying to understand better, or also just like query. And also you have you know, maybe like a database with geospatial data they're trying to understand better and get insights from. And so your generic chatbot wouldn't necessarily be able to give you the proper source of truth. It sometimes might hallucinate or give you wrong answers, or like no, might not necessarily be exactly what you need, from your own data set. So RAG was just is basically just a way of grounding and retrieving relevant information from your own data set using your own information, and it also helps improve accuracy of like the different chatbots. So just using your own information across the board. So on the screen is just a chat application that I built to demo during the DevFest. And so this just had like your different chats, different types of chats. So your simple chats where you're using the base Gemma model, where you just chat with Gemma the way it is, and it doesn't really have context of what you're speaking about. So let's say I have a PDF of the talk for today. If I ask it about that, it really doesn't have, it's not grounded on that information, so it doesn't have that context and would just hallucinate and give me anything that it thinks I'm trying to talk about. And then the enhanced one was just more of like grounding, or basically just having more context. So you're able to add more context to your information, to your query. So basically tell it, maybe you're an advanced chatbot that is maybe an AI expert or something like that, and it can give you the information that you need. And then there was the RAG chats that kind of, you upload your document and you can ask questions based off of that document. So it literally is grounded on that information. And so just a brief overview, and I'm sure some of you in the audience are wondering why I'm taking you through this. This is basically, so first of all, this is uh, the process of RAG. This is like a broad overview of what goes on behind the scenes. And the reason why I'm doing this and taking you through this is so you can get a good understanding of, before you build an agent, before you get to that step, how exactly do these things work? Because most times we just focus on, like, we just see the interface, but we don't necessarily know what's going on underneath the hood. And yeah, this basically is a kind of like first steps before moving on to the whole multi-agent system. So first things first, you have your data source, which is maybe your PDFs or your relevant database or any documents or anything that you have. And then we go through like the trunking process, the embedding process. So trunking is basically breaking up your data into more understandable pieces. So you can't just like feed the whole information to the model. You need to break it down and also embed that data to ensure that the information in that in your resource can be understood properly by the model. So embedding is basically just converting, maybe let's say you have a text-based document, uh, then you converting those texts into, you first of all convert them into smaller bits and pieces, and then you kind of convert that bits and pieces into vectors, which is like numbers, right? Numbers that can be understood by the model. And then you run like, you do like indexing, so basically trying to see what's relevant and what's not. And then you store all that information into maybe like a vector database. And also you have your query over here, where you maybe type in, what is in this document, or any question like that, or any query like that. And that query also gets embedded, which is converting text to, vectors, or converting text to um, numbers. Let me just use numbers. And then all that is fed into the retrieval process. So basically, matching whatever query you have to the vectors that have been stored, and then be further ground the information and do some other complex things over here to get the final information. So this is just a broad overview of the RAG process. And this can be one agent in your multi-agent system. And so this is just like a QR code to some of the previous talk I gave, but also the assistance, the documents, and the article. So I just want to give a disclaimer that I haven't tested out the assistance in a while. So just in case it's offline, I'll make sure to bring it back online. But you can scan the QR code if you want more information about that process and how that works. And also there was an article that also details the RAG process and how you can kind of like own your own information and own your own model building. And more of it is like, this process helps you to not you can kind of build things locally, so you don't necessarily always need to like send out queries or whatnot. So if you want to build your own in-house AI, you can literally use this process to do that. Okay. And onto the next step was giving a talk on beyond retrieval. So beyond the RAG process and retrieving data and whatnot, we wanted to see how we could accelerate AI development with the Google ADK, which is also in line with what we're talking about today. So this was a talk I also gave at the Devfest Johannesburg this year, 2025. And this would also be like a foundation, or this is a foundation to the talk today. And I wrote an article on that. So if you want more information, to be honest, this article also speaks to what I'm talking about today. So it's very helpful if you go through it and also get more information on that. It also is more in depth rather than just like, slides or whatnot. So you can get to understand the core concepts of ADK, how it works, how the different multi-agent systems work, and just gives you like a broad overview of everything. Okay. So now straight into the main content of the day. We're going to be speaking about the limit. So what exactly is, the limit of an agent, and why exactly do we need ADK? I'm going to be giving you more in-depth conversation about ADK, but for now, speaking about, what is an agent and why exactly it fails. So first of all, think about the RAG agent, so the one that does the retrieval and things like that. So why exactly does this fail? You can have one single AI agent, and it fails its complex branching. So once things gets a bit more complicated than just the baseline of maybe retrieving data and doing some few things, then it becomes a bit difficult. But then you also have a situation whereby the RAG agents might be good at one thing. So like, you ground the data, maybe it's text retrieval, and also just maybe understanding a particular context of, maybe you're an AI geospatial scientist, or you're an AI writer, right? So you kind of give it more context as to being a great writer, but now in terms of like other aspect of things, you might not necessarily be as good as doing that. And you think about this in line with like if you run a company, you can't necessarily be the CEO, the developer, the marketing agent, you can't be everything all at once. You have to have your domains. You have to specialize in one thing. But what helps the company run is the different functions or the different people. Let's say in this instance, the different agents being being focused on their area of specialization, being great at their area of specialization, but also being able to interact with each other, and also like leverage on information all that they all have. And yeah, so this is, the focus of like making things more multi-agent. And that, to touch on another point, is just when it comes to real world automation, that becomes very, very complex, branching logic, specialized domains, and like long running states. So where you have like, oh, retrieve this and do that, and maybe you're trying to build a whole let me use an instance of you're trying to book a flight, and there's an agent to, or if one agent wouldn't be able to, you know, go retrieve the price data from the flight, the airline's website, then also, pay for it, then also, get your credit card information. There are so many different moving parts, and that would be difficult for one agent to do. And also sometimes you might just get like inaccurate results due to context overload, poor tool selection. And this is just like, you know, just overwhelming the agent. So we need to ensure that across the board there are multiple different agents that are working. But yeah, so the solution to those problems that I highlighted is just having a multi-agent system. So this is just where a system where specialized agents cooperate and coordinate to achieve a shared complex goal. Like I mentioned earlier with the CEO instance, whereby you have a company, the CEO is very, very relevant and very important in the company, but also is the developer, also the marketing team, the product team, the different specializations are very necessary. And it also ensures that if maybe and even amongst the developers, for instance, you can also have multiple developers, right? So they have the context of what a developer is meant to achieve, and they can all work together in achieving that goal. And it also ensures modularity, robustness, and ensures that like there's always like a fallback. So when something goes wrong, there's another agent that can carry on and like move on with that. And so now I've given you kind of like the end of this. I brought it to the beginning because I wanted you to understand why exactly agents are necessary, and why exactly we need these multi-agent systems. But now let me speak about ADK. And I don't know if maybe we have a comment section over. Oh, okay. I'm not too sure we can do that, but I wanted to say. I wanted everyone to kind of write in the comment section to see if they're quite familiar with ADK, or they've heard about ADK, because this is relatively new. It was announced in earlier this year, I think in May or so, or March, at the Google Next Google Next this year, and that was when it was introduced to the public. So this has really elevated and accelerated the whole building of different agents, or the whole building a multi-agent system, a more robust multi-agent system. Okay, so yeah, like I mentioned earlier, it was introduced at Google Cloud Next 2025, and it's just basically like a flexible framework for building and deploying sophisticated AI agents. So it basically simplifies the end-to-end development lifecycle of AI agents by providing a code-first toolkit for building, evaluating, and deploying systems. So this, to just summarize all of this, it basically simplifies the process of having your different agents. So I talked about having, um, you know, there's a monolithic agent doing one thing, and now we talked about the best solution for that is having a multi-agent system whereby we have more different agents with different specialities or whatnot. But now, how do we ensure that they can talk together, talk to each other together? How do we ensure that we're just not building things in silos, but all of them, they all have like context of what each one is doing, and how to make sure uh, basically we get a valid outcome out of all of this. So this is where ADK comes in, and this is where it's very, very helpful. So I'll just leave this on the slide for a sec so you can also go through it. I know there's that lag. I don't want to be too fast, and if I'm too slow, also let me know. Okay, so let me move on to the next slide. So this is just an example of what happens with ADK. Earlier on, I did show the process of RAG, but also this kind of encapsulates that process, but also includes other aspects to it. So we do have like your data source, which is similar to the RAG data source, and now the ADK agent development kits assist you in having like your different models, your different adapters, your different pipelines. You can have all that encapsulated into one, so you don't necessarily need to be using like different tools and different architectures and things that are not compatible with each other to like build the systems. You kind of just have like it's kind of, I wouldn't call it like directly like a plug and play, but all you need to do is to spin up maybe ADK web, and just define your different agents, and then you can just define your agents and also just like dictate what you want the agent to do, and they just kind of are managed in that way. So basically what to give like a more visual approach to this is you can have like your different functions with your different agents in them, and then you have like a parent function which can call each and every function to do what's necessary. So let's say you want the agent to check the weather at a certain time. You can have an agent for weather checking and an agent for time checking. And then, when you send in that query, one agent does the time checking, one agent does the weather checking, and then they consolidate that information and then give you your output. But now apart from that, you can also just like deploy all of that and, have it as like a bundled piece of software. Okay, so this is just a brief overview of how it works. So it's just like your different agents, your tools, orchestration, callbacks, and some few other things. I'll go into more depth in a bit, but this is just like an overview of what's contained in your ADK or in the agent development kit. Okay, so just a quick rundown. So basically, the simplistic view of it is all you need to do as a developer or as someone building with ADK, you can, we have people even outside of the development space building now with ADK. Let me just see. I see the screen is still showing the previous slide. So okay, now let me let me switch to it. So as a developer, or as anyone building with ADK, uh, all you need to do is to define the goal and scope. So what you're trying to achieve with that agent. So you want to um, have an agent that can assist you in becoming a better developer. So you want it to maybe have context of your yeah, I wanted to have context of the latest articles on on developing, or the latest articles on you know software architecture, multi-agent systems, and other concepts. Then you also want to be able to design the different agents. So one is good with software architecture, the other one is good with AI knowledge, the other one is good with different things. You also want to design how they're going to be interacting with each other, and then you can just after you define that and you design the way they're going to be interacting, build agents and tools around that. So one just as context of the different books in the software architecture catalog, the other one as the access to books and information on AI development and things like that, and so on and so forth. And then you just configure and connect all of them together and see, when you're asking questions or when you even, let's say you also have an agent that actually helps you build based off of this information that it's gotten from some of those books and the relevant context. So you also have another one maybe that has access to what they call it, docs. So design docs, and also just like docs around different APIs and things like that. And so when you configure and connect them, it can basically, you can also have an agent that does the building for you. And so it basically has context of like all these different, uh, recommended patterns and approaches to actually build something. And then, you can deploy that and then maybe just ask, oh, can you build, um, you know, can you build a new Google, for instance, or whatnot? Obviously, that's far fetched, but just for you to have a visual idea of what I'm talking about. And when you say, can you build a new Google, it goes to check, oh, how exactly is Google built? What are the principles, in building like software like this? And then you can also deploy that and monitor what's going on underneath to like debug and see if, things are right. And then when it comes to evaluating, you can also have like another agent that does the evaluation for you, but you can also like inspect to see what exactly is going on underneath the hood, and then you can just deploy that as a bundled software. Hmm. So yeah, so let me just see. So why exactly are we using ADK? Alluded to most of that earlier, and I think I'll also just brush over this now. So we can build a RAG application, but what's next after building your RAG application? You've done all the different processes with RAG. How exactly can we build a more useful ecosystem whereby we're talking about AGI, we're talking about having having different systems, or like just being able to, just send a query out and have like a fully fleshed out system built out. And how exactly can we do this? We need to obviously build, different systems, or like similar to with the software space where there was like APIs and SDKs and whatnot that assisted us in making sure like we can interact with the different systems or whatnot. This is where ATK also comes in for AI, where we have like different agents that can interact with each other, and we kind of are building an ecosystem, not just like a standalone agent. Okay, and this also helps us managing complex multi-step reasoning and dynamic tools to use without getting lost in the boilerplate code. So another thing is, how exactly do we evaluate the agent's performance? Let's say we have one agent and we're just like, okay, this is good at doing one thing, but how exactly do we know that it's actually doing the right thing? This, we can also have another agent that actually evaluates it, and then we deploy, we scale, monitor, see how everything is going on, everything goes on. Okay, and now onto another core aspect of this. Um, so we're going to be speaking about, so I'm going to be touching on some architectural patterns of how this works. So let me just confirm. Sorry. Okay, I see we're still on the previous slide. Just wait for that to update. Yeah. So Currently, I'm just going to be going through some of the architectural patterns. One of it is just sequential orchestration. So where you have a manager agent that receives the tasks, breaks it down, and then sequentially ends it off to different worker agents. So you have the different worker agents, which I didn't mention. So let's call them children agents that just do you know, their different specializations. They just handle whatever they need to handle. They don't necessarily have context of the full thing, but the manager agent that has context of the whole goal and scope of what's meant to be done, then can manage each and every child agent to do what needs to be done. So um, an example would be a multi-step process with like research, draft, summarize. So you can have an agent that researches the draft, another one that drafts based off of whatever is researched, and then another agent that summarizes. And the main manager agent just it dictates the flow of how things are going to work. So, and the worker agents focus on the subtasks. So the main manager agent, like I mentioned earlier, just tells it to do this, do that. I want to see if I have enough time to. I'll just try to quickly rush to this. And if I have enough time, I'll just show you how this also works in practice in the code. So another another architectural pattern is critique and reflection. So this basically the maker agent generates output, and then a separate one checks and critiques whatever output was given. So that was similar to the evaluation step I mentioned earlier, whereby we just trying to make sure as much as one is doing the work, and we want to ensure correctness, especially when it comes to production systems. We don't just want to build and build, and then there's no way of evaluating to see if what we're doing is correct. And with these evaluations, we can then we can build up on this and fix whatever issues that we face before we start serving anything to clients. And so this is like code generation, and so for instance, making sure that there are no bugs in the code, or making sure that the code aligns, or the code aligns with the spec, that the spec of what's meant to be done, the product spec, and also just ensuring that like the code quality is top notch. And then the maker checker loop can iterate until the output meets the standard. So it just keeps improving itself. This is similar to what happens in like reinforcement learning for those of you that are quite familiar with that. And then we just increase the reliability over time of this code generation process. And then there's also the agent handoff. So this is just like bringing everything together. So I'll do agent talk. So basically the different methodologies. So let me say like either using structured data, or using callbacks to basically send information from one agent to another. And then there's like a trigger. So once one is done doing a certain task, there's a trigger that allows the next agent to continue the other tasks that it needs to do. So based off of the full goal. And this just ensures the state, the current task and context is preserved, and the next agent knows what exactly we need to do. So it's just passing it across the board, so that we don't necessarily have like blocks and whatnot, whereby one agent is done doing whatever it needs to do, and then the other agent is not doing what it needs to do, just like freezes, or it just doesn't do anything because it has no context of the fact that the previous agent is done doing its tasks. And then yeah, so then the more complex multi-agent system architecture, where this is where the manager agent receives the tasks, breaks it down, and sequentially hands it off to specialized worker agents. And then the manager just orchestrates the code generation task, worker writes the code, checker critiques the code, loops until it's approved, and then the manager passes down the deployment work. So this is like an end-to-end system from getting whatever task needs to be done to deploying it to production. Okay, and so this is actually something I mentioned a bit earlier. We have Hmm. You can have like multi agents, and so main the main manager agent would have context of all of this, right? That's this full. Let me just confirm that you guys can see what I'm talking about. Okay, so I see we're on the right screen now. So think about it like this: the manager agent as context of this whole thing, so everything that's going on, similar to you as whoever is building the tool. And then the user sends in a query, what's the weather like in New York City? And this can apply to any other city, you know, based off of whatever preference and definition that you give. And then you have the agent, which is the weather agent. Uh, which is the main agent, sorry. It receives and processes whatever query you get. So that's this, what's the weather like? And then you kind of decide which one to call. There's the get current time, and then there's the get weather. And then this kind of this agent basically decides what needs to be done based off of what the query is, and then we consolidate the idea. The agent processes it, formats it in the right format, and then sends it down to the user. So this is kind of like a broad overview of what we expect in these systems. For the most part, this is very, very simplistic. This is just like two different agents. This is two different tool calls actually to the two different agents, but we can, in this same breath, we can actually have multiple different agents. And we just need the one agent to have context of everything, and then the other agents just focuses on what needs to be done. So I do see I might be running out of time. So let me quickly um, go through briefly go through the core components of ADK, and also then just take you straight to the governance aspect of things. So I've talked about agents. I've mentioned briefly about callbacks. I mentioned a bit about tool calls and tools, and I just like mentioned some few things, but I didn't go into depth on it. And so on, let me just confirm that this is the right slide. You guys can see. Hmm, okay, so yeah, on the right slide. So what are agents? So these are like just fundamental worker units. So they're designed for specific tasks, like I mentioned. So you have an agent that's doing this and that and whatnot, and this basically they just think about them as people in their different specializations or specialized agents, and then you have your tools, which gives the agents abilities beyond conversation and retrieval, and it allows them to interact with different external APIs. So just think about it as like, allows the agents to actually reach out to other, um, to retrieve other information. So maybe you've connected your agents to like a search API, so you can basically, if for any other context that you need, you can always retrieve the information from whatever the search API, and then give a more concrete response to the user. Then you have callbacks, which just provide which you can provide to run at specific points in the agent process. So it just checks logs and behavior. So this also helps, the different agents communicate with each other. So once one is done, it just gets a response, and it gets notification that the one I mean, once one agent is done, the other or the next agents can also get notification that that agent is done, so he can proceed with doing what he needs to do. Most of the time, he needs information from the previous agent to do what he needs to do. Then we also have things like session management. So this just handles, whatever conversation is happening in that session. So it gives like a broad history, or like it just gives the agent's knowledge of what's going on. So he doesn't necessarily like lose context. So he knows that if you notice in with Gemini, when you have conversations, it keeps that chat session, and you can always go back to that chat and continue as you wish. And it just knows what the agent is currently working on and things like that. Then you also have memory, which records information about the user across multiple sessions. So maybe you want like a broad overview of everything that has been going on, and everything that is happening. So this memory just keeps that and allows you to get it back as you wish. And then you have artifact management, which saves loads and manages your files. Then onto, yeah, just wrapping this up. Then we also have codex, execution, planning, and models. So models are very self-explanatory. So that's like the brain of of the ADK. So that just allows you to do more. So in terms of, you have your Gemini or your Gemma that already has context of like it's already trained on like so much information. So most times you don't obviously need to go check elsewhere or anything. All the information, like the information can be gotten from the model, but obviously if the model can't necessarily process it or handle it, or doesn't necessarily have like solid context of what's going on, then you need to obviously include more APIs, or I mean more agents to do extra things on the side. So yeah, and then code execution and planning, those are also relatively self-explanatory. And yeah, on to, I think this is like the last section of this talk. So this is governance and observability, and this is also what makes this process uh, more deployable into the real world space, and especially onto production. So the main challenge with this is also, we've spoken about the different agents. We've spoken about how they can work together. We've spoken about why we need that to be that way. We've spoken about moving on from RAG and also making things you know a bit more complete. But now, in a situation where you have multiple agents, it means that like there are more things to happen and there are more things going on. There's definitely more costs. There's definitely more. There can be more data leaks, and there can also be like lags in performance. So maybe one agent is failing at what it needs to do, and it's just runs into like an endless loop. How do we manage all that and all those processes? How do we make sure we build a more robust system? So this is where things like monitoring and observability comes in. So basically, this is now utilizing some of the methodologies that we already know from, for those who are familiar, we already know from like, the cloud system, or like the already existing systems that we have. So those things are not antique, they're not out of date, they're still very, very relevant to what we're doing now. And in that instance, we have adding more traces, more logs to these different agents, whereby we can kind of see what each and every agent is doing. We can try, so using like things like Cloud Trace, for instance, you can follow the request and state data across the entire multi-agent workflow, and pinpointing where the errors and latency occur. So kind of like just knowing exactly which agent went wrong, where did it go wrong, what is going on. We also like log, the different activities of the agent. So maybe the agent is retrieving, let's say we have a retrieval agent. The agent is currently retrieving data, and maybe you faced an issue where maybe it's the agent is actually like a text retrieval agent, but now the client or the user actually wants to retrieve, something outside of text. Maybe I want to retrieve a more, maybe geospatial data, or like just more complex data sets. And that agent can't necessarily handle it. We need to be able to like log that, and once that's logged, it needs to be able to be picked up, so maybe another agent can actually handle that process, because we should have multiple agents that caters for that, basically fallback agents that caters for, the more complex tasks, and we don't always need to use the more complex agents every single time unless when necessary. Hence, even in your Gemini, you kind of have your fast agents and you have your thinking agent, and thinking agent is a more expensive agent because it does more than just like gives you like just the information. It does um more under the hood than what the fast agents would do. And then you just have monitoring, so just like different metrics. So maybe you're looking at costs, or you're looking at how many agents need to do a certain task. So basically just the general monitoring and observability um approaches that you have for your other systems. And yeah, another thing to look into is cost. You're paying maybe per API call, or you need to manage that process, and you don't necessarily want a situation whereby your agent is requesting information that you don't necessarily need to request at that certain point. Maybe there's already like information in the grounded data or whatnot, that you can just retrieve from like that data or the database. You don't necessarily want a situation whereby the data is still making API calls and like going back and forth or whatnot. And so um, the main issue obviously would be the amount of agents, the amount of API calls, the amount of like the cost would obviously wrap up or like keep going up with the different agents and like the different tasks that they have. So maybe you can just have one agent actually that caters for um that reaches out to the API. That reaches out to the model. So like that reaches out to whatever model that you need to reach out to. And you can have, like I mentioned earlier, you can have like the more complex agents that takes care of more complex tasks, but by default you have like a smaller agent. You have an agent that interacts with the smaller models, where like your Nano, Gemini Flash, whereby you just like you know there's like simpler tasks where you don't necessarily need to scale it up to the biggest model to do something that is simple, like what's the time. You don't need Gemini Pro to get the information on what the time is. You can even sometimes you can actually just do like a different check compared to like just using a model for that. But then you have the models to implement, or to you have the models to be able to go through or give like proper responses, or bring the information together, but also give proper responses based on whatever complexity the task is. Okay. And I'll so on this next slide, I'm not too sure if I haven't gone over time. So at this point, I would have loved to take you through this. So this is it's basically open source. You should be able to have access to this. And I wanted to direct you to this page where you can actually interact with an agent and see how you can actually build a multi-tool agent using ADK. So if you scan the QR code on the screen right now, you should be able to go to that page, and you should be able to uh, see it's well documented, and you can go through each and every step and kind of build your own agents. And you can literally utilize the AD, like you can just run things using like ADK web, and you can see how the different agents interact with each other. And let me see if there's anything else. Oh, questions. So if you have any questions, just let me know. You can include that, but you can also reach out to me. I'll include as a slide where you can, send me a message or ask more questions about this topic. And if or even want more information or access to the slides, some resources or whatnot, I'm very eager to share that with you. And uh, just engage on this. And if you just want to chat about it, if you're just like keen to, have a conversation on like AI and the agentic system and things like that, I'm very keen and open to chat about this. Yeah. And if you'd like to connect with me, you can scan the QR code on the screen. And so, I'm on LinkedIn, Medium, X, and also you can check out my website over here, and just send any feedback you like to send. I'm always open to chatting and also engaging on these topics. Very, very passionate about ML, about AI, and also building with Google. So yeah, thank you so much for the time. Thank you so much for listening, and looking forward to the chats and also getting any relevant information from you guys. Let me know if you'd like me to go back to anything or touch on anything. But in the meantime, I'll just go to the references. Let me see. So I'll just go straight to the references. And yeah, you can also scan the QR code for the references and get more information on some of the few things I mentioned in this talk. But yeah, thank you so much, guys. Thank you. Mm. Okay, so I just got information that can be able to take you guys through some of the things I talked about. So maybe just few minutes, I'll just quickly go over this. Um, so yeah, this is the official ADK page, and if you scan the QR code I showed earlier, if you can scan this QR code, as showed you guys earlier, you should be able to see some of these things, and also some of the things I talked about earlier. You should also be able to see them here. And if you want to start with Python, there's that option. So you can do like a quick start, and you just all you need to do to actually get running with ADK is just pip install Google ADK. And then I did talk about agents earlier. So this is kind of like where you define your main agent code. Okay, I see it's still a bit laggy, but let me just slow down a bit to ensure we're on the same page. Okay. So yeah. So this is how you define your agent project. You just have a folder that has like the agent name, and then you always need to specify the fact that there's an agent.py. You also specify your init file. So for those of you that are familiar with Python, you know what init is, init does, and the agent's file, just mainly everything related to the agent should be contained in this agent file. As it says here, contains a root agent definition, which is only required, which is the only required element of the ADK agent. You can also define tools for the agents to use, updates to generate, update this to include your general, your get current time, which is the stuff I alluded to earlier. And this is basically what you can define in your agent file. So this is a function where you can define, the time. So this function just gets the current time. You can also have other agents uh, that also do other things. And then this is your root agent, which is like your main agents basically. And as you can see, these this different functions or methods are just defined as tools. So when, let's say, so this is an instruction, tells the current time in a specified city. You're in an L4 system that tells the current time in a specified city. And so this basically has context of, this function and can just return that. But let me see if I can go into, uh, there's a more complex one. Yeah, build AI tool, multi-agent tool. So this is another one. And this is what I was going to take you guys through earlier. I see I need to wrap up in a bit, but I'll just do like a quick brief of this. So this is a get weather function, right? Which, gets the city, whatever city is specified, and then it just returns this information. Else, if you don't specify the correct city, it errors out. And then this is the get current time. But the most important thing is, so these are the different methods, which that's fine. Gets time, gets the current city. I mean, gets weather in the current city. And then the most important thing is how this agent manages both of them. As you can see, gets weather over here, would get the weather, and this would get the current time. But then this is basically the agent is meant to answer questions about time and weather in the city, which is, if you notice the picture or the diagram I showed earlier relates to that. And so, as you can see, even we're also not using like the most complex model out there. And so this basically manages these two tools, as we call them in the ADK terms. And so you can basically get the information, and you can have multiple of this, like get country where city is in, or get the seconds, or things like that. You can basically have multiple like that, and then this basically spits out the relevant information that you need. This root agent does all of that managing, and this basically is how you can have your different agents. So let's say this is one agent, this is another agent, and you have multiple, like a lot of them, and you can just define, like, call all of them here, and then whatever question is being asked can be responded to, and this would help determine what tools are called. So yeah, I would implore you guys to go through this and a couple of other things, and also check out my articles, my blogs. I do also describe this in more detail, and then I also would be publishing more around this content. So um, stay tuned, and thank you so much for the time. Thank you so much for staying put and listening through this talk. And yeah, good luck on testing out ADK.